Hey y'all, example 2 on the Weirstrass substitution, and yeah, if you haven't watched example 0, then you should pause. Okay, I'll stop because at the start of example 1, I did enough preaching of why it's so important that you watch example 0 on the Weirstrass substitution, so I won't do as much preaching here. But yeah, as I'm doing this integral, if it seems like I'm pulling some things out of thin air, it's because you haven't watched example 0, so it's all your fault. Alright, now, in example 0, we said that all Weirstrass substitutions start with tan of x over 2 equaling u, and from there it follows that dx is 2 du over 1 plus u squared, and then cos x will be 1 minus u squared over 1 plus u squared, right? So if you watched example 0, then you'd know all of this, and you would know that this integral will then turn to 1 minus u squared over 1 plus u squared over, and then 1 plus cos x is going to be 1 plus u squared over 1 plus u squared. This is the 1, that 1. And then plus cos x, which is 1 minus u squared over 1 plus u squared, right? And we still have to write dx, but notice what happens here. This is cos x plus 1, or 1 plus cos x. What happens is, well, in the numerator, this is going to cancel that. We're just going to get a 2, right? So we're going to get a 2 over 1 plus u squared, like that, right? And then, of course, this is going to cancel that there. So really, like, this whole quotient, other than the dx, turns to 1 minus u squared over 2, right? Okay, so we have 1 minus u squared over 2, and then of course dx, we said right here, is 2, and then du over, and then it's 1 plus u squared, right? Okay, so this happens, right? This 2 and this 2 cancel, right? So good. And so we could write 1 plus u squared right here, right? And then get rid of it from there. So this is what we've got, right? Okay, where to from there? Well, I think we should do this, which is we should now write this integral as integral of 1 over 1 plus u squared, and then minus u squared over 1 plus u squared, and then du, right? But this part should be easy to follow from what I have here. Now, here's what I'm going to do. I'm going to cleverly put a minus sign right there, and then here I'm going to add a 1. And then, of course, I need to make up for it by writing this, right? But this, I have to have a parenthesis right there to do what I just did. So minus, and then 1 over 1 plus u squared, and then du all the way down here. That's fair, right? Other than this parenthesis being too big. Okay, it's fair because, like, if we distribute this minus sign, right, we get minus u squared. That's right there. And then we get minus 1, and then plus 1, right? So, like, this is the same as what I had there, right? Okay, cool. So like, I'm going to, yeah, right, like, get rid of this parenthesis, keep the minus sign right there, and then as I need, distribute it there, and get rid of that parenthesis, and this is what I've got. Oh wait, this guy and this guy, they look identical. So I go like this, right? And then du right here. Oh wait, this is just 1. So yeah, okay. So I go 2 tan inverse of u, and then minus u plus c, right? And then we recall u is tan of x over 2. So the answer here, final answer, is no, my bad. Tan inverse of tan of x over 2, and then minus tan of x over 2 plus c, right? Now, other than this 2, tan inverse and tan undo each other, so we're going to get, and then when we multiply by 2, we're going to get 2 times x over 2, so that's just x minus tan of x over 2 plus c. Yeah? Okay, cool. I will see you later.